Good night. Can you guys see my screen?
Good night, sir. Yes.
All right. So last week we started this paper. Um, January 2023, paper 2. We worked questions 1 all the way to question 3. So today we're going to be starting from question 4. So the first question states an algorithm is needed to read the age of each student until it reads an age of 999. It should then calculate the average age and output both number of students and the average age of all students. Complete the IPO chart below to define the problem by decomposing it into each of its significant components: input, processing, and output. So what is going to be your input? What is going to be, well, let's look at that first. What is going to be your input?
The age of the student.
Good. So age. Anything else? Or just age?
And the number of students.
The algorithm is needed to read the age each student until it reaches age 99. Should then calculate the average age and output both the number of students and the average age. Not necessarily. Because we could do some calculation and get the number of students. Anything else for inputs? Anything else we could add for inputs?
Sir, I don't think so, no.
All right. So it doesn't technically mention anything else, but we could technically put the student's name to differentiate each student, but I don't think they would require that. Oh. I was about to sneeze, but it didn't come. Yeah, it doesn't necessarily say we have to put the student's name, but it won't hurt to put it in. It should then process what? What is going to be our process?
Sir, I'm not sure, but I think it would be a while loop. Where it would be something like while age is not equal to the age of 999, the say we use sum, we could say that the sum is equal to sum plus age. Hold on, give me a second.
We're heading in the right direction though. Let's see. Now, this is a IPO charts, and we don't necessarily need to use all the right acronyms. You can basically just write it in layman's words if you want. But it would be good still if we could write it in at least as close as possible, maybe to the algorithm or the pseudocode. So we can say something like while loop if age is less than 999, then we basically got to add all the age. Then we can say add all age, or we can say total all age, or something along that line. And before we get into that, we make it simple, because we got to calculate average age first. So we can say average age equal total age divided by number of ages entered. So we need to calculate that average age first. So then this one is going to be, if age is less than 999, then add all age.
Excuse me, sir. Do we need to state a variable specific for like the number of students?
At this stage, we don't need to do variables.
So when we're putting it outputting the number of students, how would we exactly know how much students was in the entire process to calculate the average?
That's what I'm looking at right now. You got to run a loop. So that's where the loop is going to come into play. Aren't you guys supposed to be telling me how to run this loop to calculate the total? Because we have our average, calculate the average age. That's going to be the total age divided by number of entered. We got to output, so average age, number of students, but this is the output. Yeah, nobody else is saying anything.
If I could say anything else, I would, in all honesty.
But like I said, I don't think this calls for all of these technical things that we're doing right now. Basically, we can say, like, well, we need a loop. We still need a loop, so we still gotta go in this direction. Because if age is less than 999, if it is true, then add all the age, count plus 1. We need something like that. Basically, that's what we need. Count equal counts plus 1. As we got a 2-part, then add all the age, and while it adding the age, you need to increment this count. So this here is going to be total age. So while loop, if age is less than 999, because we gotta work until the person reads the age of 999. If it is less than, then total age equal total age plus age, something like that. If age is less than 999, then total age equal total age plus age. Because the person enters the age, it can be added to total age. And we increment count to count the number of students. And then we calculate our average at the bottom here. We take the total number of students. What am I saying, students? We take the total age, and now I can substitute this with count, because count can be the number. So total age divided by count is going to give me average age. And then output is going to be number of students and average age. So we take out the student name thing. So we can see where the 5 mark is coming from, because it's 1 input, 2 process, and 2 output. So if you guys can remember from the SBA, the IPO chart is just to document what is going to be your input and what you're going to calculate, that's your process, and what you're going to output. So if you want to put it in variable form, that's up to you, but just writing it out, that could work also. But just to have like an idea what is going to be input, what you're going to calculate, and what you're going to output. So let me just go through it again. Algorithm is needed. Chance you have a 2019. I'll get back to you later. It's such a related question. It's a possibility. An algorithm is needed to read the age of each student. Okay. Until it reaches an age of 999.
Sir, for when it said is needed to read the age until it reads. So for the processing, would you include a part where it says like ensure that the like the first thing that you should do is read to see if the age is actually 999 before you carry out any loop or so? Oh, sorry.
Yes, so that's why I have that. So I'm checking to see. Remember, a loop has a test, and that's why you call the while loop, because the while loop has the test at the beginning. So that's what we want to do, to test it at the beginning. So we have our test here. If age is less than 999, then if that is true, we continue with the loop. And it's a bit straightforward with the statement. You just gotta look for the keywords, an algorithm that is needed to read the age, so that's input, each student until it reads the age of 999. So this is gonna be what's gonna stop the loop. It should then calculate, that's process, average age, and then output number of students, average age of all students. Yes, any other questions? Tamika, you think you understand what happened there?
Yeah.
All right. So let's continue. The following is the pseudocode for the algorithm mentioned. So we have start, set count to 0, set age to 0, set average to 0, set total to 0, write, enter student's age. So this is the start of the algorithm. Read age. While age is not equal to 999, I think that's not equal to, right? That's not equal to, right? Nobody?
Using context clues, yes.
Yes, so this is not equal to, and this one here is not equal to. So not equal to, set total, so total plus count, then go into that, count plus 1, write another age, or enter 999 to terminate, read age, and then the loop, ended the while loop. Then you calculate the average, outputs the count and the average, and stop. So, a trace table. Test the pseudocode for correctness by completing the entries in the trace table below for each loop of the algorithm. When the algorithm reads each of the following age values 18, 26, 39, 999. So 18, all right, let me start with 18. So it says when a person enters 18, total is going to be at 0. Is that true? Will total be at 0?
Sir, according to the paper, yes.
Is that true?
I don't think so. When you enter age, then it's isn't it supposed to go up by 1?
Total? Total. Does total have an increment?
No, it doesn't.
Technically it does, right here. But it's the first loop. This is loop number 1. The program just starts. And what does total start off with? It starts off with a 0. So it was initialized with a 0. So this here is correct. It is supposed to be 0. So what is count supposed to be? What value would count have?
Count would also be 0.
Correct, because count is also initialized with 0. So that's going to be 0 there. And average is going to be 0, because average was initialized with 0. Now, the person says he's going to loop now. And so 18 is going to be entered, and we got to do a calculation now. It's because you got to go through with that 18 and then start back at 26. So the person enters 18 here. Now, while age is not equal to 999, which is true, it's not equal, we come here. So total plus count, that's 0 plus 0, as both of them got 0 inside. So now total is going to have 0 inside. Count equal count plus 1. So that's 0 plus 1. Count is going to have 1 inside of it now. Enter another age or terminate or enter 999. The person entered 26. So we repeat. Go back up to the top. Now, so that's the loop there. I just bracket off the loop. So this is what we're repeating. So the person entered 26, while age is not equal to 999. 26 is not equal. So it's going to go into the loop. What value will total have? It's going to have 0. No. What value will it have?
1.
1. So now it's going to have, but see, this is the that's the pseudo-cover correctors. By completing the entries in the trace table below for each of the algorithm and the algorithm. By completing the entries in the trace table below for each loop of the algorithm, when the algorithm reads each of the following age values. So you gotta test when it reads the age value. So at this stage here, as that's important, it's not after we go through this loop here, then we read it. It's when we read this when we're currently reading this 26. So right now, what value does total have at this stage here?
0.
0. But it says count as 2. See, this is the part that doesn't. If that means, if they're saying count as 2 there, then technically that means they went through the loop.
Sir, I think there was a mistake with the pseudocode that they gave us. Because if I remember correctly, when you scroll down and you read the rest of questions, they said that some line had an error that we need to correct.
But it shouldn't affect this pseudocode trace table. It shouldn't affect it. Let's see. If it goes through, you enter 18, it reads total and count. It doesn't have anything inside of it. Total and count. Alright, so, and then 1, count. So that means this count is supposed to be 1. So what's happening here? It's going through. It's reading and then going through. And then up to here, you're basically carrying out the trace. So you're reading and going through and then carry out the trace. So it's a bit tricky because you got to figure out those kind of things. At what point you're tracing basically. So we figure that out, that we have to go through up to this line here, everything, and then trace up to here. So basically, let's start it over. So the person entered 18. This here is going to be true, so they went in. 0 and 0, we're going to give them 0. And 0 plus 1, that's going to give you 1 there. So total is going to be 0, count is going to be 1. So we have that there now. And then average is going to be 0 because we didn't calculate any average. So basically, technically, average is going to be, well, not at the end here. So now, we enter 26. Yeah, we enter 26. And That's going to take us back up to the top here. And count is going to be 1. Total plus count, 0 plus 1. Total is now going to have 1 inside of it. And this is going to be 1 plus 1. So that's going to have a 2 inside of it. So that's going to be 1 and 2. So total is going to be 1. And count is going to be 2. How much will average be? How much would average be?
Sir, 0.
0, because there was no change to it. Good. Now, the person entered 39. What is total going to be?
Total becomes 2.
Are we sure?
No, it becomes 3 because total is 1 and then you add in count, which is now 2, so it would be 3.
Tamika and Accurate, you following?
Yeah, I missed that.
Yeah, so this is why it's important to write down the information as you're going through. So we're going to erase this 0 here and take this 1 from over here and put the 1 here. And we're going to take this 2 and put it here. So that's going to be 1 plus 2, give you 3. Our total has 3 inside of it. Now this 2, we got to take it and put it over here. So 2 plus 1, this is going to be 3 also. So this is going to be 3 and 3. And this here is going to remain at 0. Now, why did total go to 2? Did we do that right? Or just did that to throw us off? Anyway, that's the correct thing though. This 2 has to be wrong. Because we were tracing it correctly. Either way. So they entered 999. So they went through the loop. Right age, enter. And it terminates there. Now, what will average be? No.
Sir, I would like to assume 1 because after 0 is 1. I don't know.
Yeah, I was gonna guess 1. I
Wait a
don't
minute.
know the reason behind it. Just guess 1.
What do you mean after 0 is 1?
Sir, because the entire table for the average yield is 0, 0, 0. So like after 0,
No,
then you get 1.
the formula is literally right here.
Yes, sir, but it said that is the total divided by count, right? So how, like,
So our last total, you got to take your last total and divide it by your last count. So that's 3 divided by 3.
yeah.
So why did they put the 2 and
So
the
why are
3
we not
there?
using the-
I don't know. I think this is to throw you off, but I don't think these values here are correct.
So like we're not even gonna acknowledge the total and the count for the last line.
Yes, we're not going to do that. Let me go through it one more time to make sure we're doing everything correct. But I don't think think they made a mistake there. As we go through the question, we might see if they made a mistake there. So 0 and 0, that's 0. 0 and 1, that's 1. And then we loop. So this now is going to become 1, 1 plus 0. This is going to be 1. And this is going to be 1 plus 1. And that's going to be 2. So that's 1 and 2. Good, 1 and 2. As you go back around, count is 2. So we got to take 2 here. Total is 1. So that's 1 here. So this is going to become 3. Now count is 2. 2 plus 1, that's 3. And that's how we get this here. Now, yeah, it got to be something wrong, but that's the actual thing based on what they have there. Something wrong with the last line. As technically this line here doesn't make sense. This total line, this is wrong. This is not how you're supposed to get total, because the total divided by count, total what though? Something wrong with this formula. Anyway, let me continue. Write the two output lines produced by the algorithm after the dry run in B1. Write the two output lines produced by the algorithm after the dry run.
Sure, number of students and average age of students.
Good. So that's our two output line, but then ensure you put the value that appear in the variable also. That's part of the output, right? Or did you miss that part?
But what value would you put?
But didn't they just say like the lines? Do you have to put in the variable? Who's gonna output too?
Yes, because that's part of the output. Write the output lines produced by the algorithm after the dry run B1. So after we complete the run, it's supposed to be 3 and 3. No, yeah. No, the count is going to be 3. And the average student is going to be 1. That's supposed to be it. Number of students, 3, because we're using count. And the average age of students is 1. We missed any colon.
Oh, so depend on what value we got for the trace table. That's what we're gonna put in for the variables there.
Yes.
Okay.
Because it says after the dry run. So basically after we complete this run of this trace table here, we have to say what's the output. Any other questions?
For now, no.
Akhilesh, are you following? Identify the line in the pseudocode in B on page 17 that needs to be corrected and state the correction to the line. What has to be corrected?
Sir, the same line that set total is equal to total plus count.
How would you correct it? So,
from the algorithm that we created, we had total is equal to total plus age. So I'm guessing you state the line and then you put the correction total is equal to total plus age.
What line would it be?
I got 9.
1, 2, 3, 4, 5, 6, 7, 8. You're not gonna count start. That's going to be line 8.
Why won't you count the start menu?
Good question. It's not something that is normally done, because it's like that's like if you're counting what, like if you're counting the line, like if you're running a race, you're counting the line, I would say. That's the starting position, but the first step after that.
Technically, if it's the starting line, it's still a line. So,
but it's supposed to be
don't
0.
you
So where would 0 be?
0, 1, 2. But like, if you count 0 as a line, then you count 0 as a 1. 1 is equal to 2, and then you get 9.
Normally we don't count start and begin and so on. Oh, this one counted. Step 1 begin. But this is more of an algorithm kind of thing. This one did it also. Well, count it. It won't hurt. At least they'll know where your heart lies.
So, if this question actually comes in CSEC,
Yeah,
and I
count
doubt
it.
myself, should I put where my heart lies as an exemplary answer?
Trust in the word.
When CSEC asks, we just tell them that Chris told us to write down the paper.
I'm gonna put where my heart lies, dash, Sir Chris.
Trust in the words.
Real.
The heart of the words. 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. Do you count start in a algorithm? Can we count an assignment as an instruction? Why what? How do you count steps? Oh, there's a whole PDF. I'm not reading that. Yeah, man, count it. What else? What else? Oh, we're supposed to determine if it's age. Total. Enter the age. Yeah, it has to be age, right? Because the enter the age, add it to total. That's what I have here. Yeah, total age plus age. Because you got to get the total age to divide it by the count to get your average. Yeah, so that was the error there. Total equal total plus age. All right, think about that question. Give me 1 minute. I'll be back. Yes, I've returned. Identify 2 impacts of information communication technology on the work pattern of employees in the health sector.
One is that it gives more accurate readings, like computers in general can give more accurate reading.
I think we need more
And two,
in-depth analysis of that answer.
it would make calculating whatever large, calculations that need to be made more accurate. That makes sense.
Two impacts. Is that an impact?
Would an impact be workers being constantly distracted as they have easy access to devices and media that can distract them?
Yeah.
But then it's health sector too. So
Yeah.
there was this thingy that robots can do surgery. Like there was a whole thing about that. So IT, it's basically dealing with programming and stuff. So then programming would include programming the robot to do that. So can that be an impact?
How about better impact? Better measurement of medicines and stuff. So
Oh, a simple one. It makes storing patients' data file like much more easier and more accessible.
good, we can work with that one.
In an organized fashion.
I doubt I'm spelling that correctly. Retrieval? No, I spelled it correct. Easier storage and retrieval. What else? Precision calculation. You're supposed to know the terms. Precision calculation of chemicals. Not chemicals, but what?
Sir, this is IT, right? This is not.
But we're talking about the health sector. What do you have to calculate precisely? What do you call them?
Precise measurement of drugs, I guess. Technically,
Big science student can't come up with a technical name.
Sir, we didn't.
Medication.
Precision calculation.
But drugs sound so much better than medication. You could have put over-the-counter drugs.
Well,
no, but then they could be measuring the robot thingy with the surgery that I was mentioning.
They could measure blood pressure more accurately, yes, and body temperature.
Good.
And heart rate. Yeah, that's it.
Good. Robots can help precision surgery. Good. So we have some ideas how we can impact the health sector.
You got survey instead of surgery.
That's that thing. Yeah, and as Akhilesh mentioned, IT can help build robots that can, or machines that can help monitor a person, various aspects of a person, and so on. Good. The workplace has changed drastically because of the ICT revolution. State one positive and one negative aspect of automation on skilled and unskilled jobs. What is the positive?
The job can be done a lot faster.
Mm-hmm. Good. So that's the negative. Replaces workers with machines. So that's the negative there. The machine helps you to do things faster. It helps you to do things better, but it also replaces persons who were doing those tasks. E, for each of the following files, state the most appropriate file organization method and give a reason for each choice. File E, meter reading records submitted by customers monthly.
Sir, I'm not too sure about that one.
Give me a second. I'm wondering if they're referring to like sequential, random, those kind of things. Most appropriate file organization method and give a reason for each. File organization. File organization. So that is chapter 2.4. File organization access relates to the use of records, fields, and files. So that's basically a database. File is also another name for table. So field is the entry point in the table. The record is the collection of the fields, and the collection of record is the file, also called a table. Serial file organization is the simplest type of file organization. The records are arranged one after another in the order they were added. That is, they have not been sorted in any particular order. Example of serial files, also called unordered files, include unsorted invoices for customers for the day and a typical shopping list. Serial files can be sorted on tape, disk, or in memory. Can be stored in tape, disk, and memory. A serial file is mainly for backup purposes. Recording data in the order in which transactions are made is also useful if you need to restore transactions that have been lost from the master file through hardware or software problems. So that is one file organization method, storing files in a serial manner. Serial meaning one after each other. So just as how you get the information, you store it. Sequential file is one in which the records are stored in sorted order on one or more key fields. So the serial is unsorted and the sequential is sorted. Examples of sequential files include invoices of customers sorted on customer number and class registers sorted on last name. Magnetic tape is sequential by its very nature, just like listening to a cassette tape or watching a movie. To access a particular section or continue from where you left off, you must start at the beginning and scan forward until you reach a specific one. So that's a two-file organization method, serial and sequential. Let me see if there's any more. There is also direct, which is also random. Direct file access, also called random file access, allows access to a particular record in the file using a key. So basically you can, unlike a cassette, whereby say this is the tape, you gotta go through the entire tape. If it was direct, you can jump to any part of it at any point in time. So that's direct or random. So this is both serial and sequential. Because serial and sequential, you gotta go in the order. And this one is random or direct. Then you also have index sequential file organization. So index sequential, it's still sequential in that you got to go in the particular order that it was stored, but each piece of entry has an index number. So this might be 1, this might be 2, this might be 3, 4, 5, and I think it can actually jump to that number. An index file is used to speed up the key search in a file. You can think of it as a one-column table, organized in ascending order and stored on disk. The primary key in the table, blah, 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 blah. It is used as an index of a book, blah, 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 to point to search location. Yeah, so it's a combination of sequential and direct. So just as I said, each part is going to have an index number, and it's called index sequential. You're going in the order, but you can actually jump to that particular index number. So,
Sir, it's basically like skipping a chapter
yeah,
without having to go through the entire thing.
right.
Okay.
So we saw 4 file organization methods there: serial, sequential, direct, and index sequential. So this is basically a summary of it here. So you have serial file and sequential. So both, so not, let me zoom in a bit. So serial and sequential, both are sequential in nature, meaning that you have to go one after each other, 1, 2, 3, and so on. But serial is unordered, sequential is ordered, meaning that sequential is organized, this one is unorganized. Partially indexed, anytime you see the word index, index meaning that each part of the data has like an ID to it, basically an index number, 1, 2, 3, 4, 5. So partially index, sequential access to index followed by direct access to the first record in the group, then sequential access to find the desired record. So basically a combination of sequential and direct, fully index, and direct access. So that's going to be random. So going back to our question, we pull it up side by side. Yes, so which would be used for meter reading records submitted by customers monthly?
Sir, serial?
Right, and why?
Because it goes in a sequential access, but it's not like sorted in a specific order. It just
No, you gotta explain why are you storing it in a serial manner? Why this type of data did you choose a serial manner?
because there is no specific order.
Think about it. Technically, it does have an order, just that we're not organizing it. Serial has a purpose. So serial, even though it doesn't have an order, it's going to accept the entry based on it being inputted. So technically, the order is actually how you're putting in the information. Even though it might be in an unorganized manner, the order is basically time-based, you can see. So especially for meter reading, you want when they enter this information, you know the exact time that they'll be entering that information. So the reason could be meter reading records submitted by monthly customers. Data will be stored based on the time of entry, something along that line. As the person enters the information, it's going to be stored in that manner.
Sir, but doesn't like sequential cover how it is stored? In
But-
what? Yeah.
Continue.
Because if you think of it, when you say serial, it doesn't have the order, but you're seeing that for the reason it's because it is being stored by the time of entry, and technically that's an order in which it's stored.
Yes, but that's something that happens naturally. It's not something that we're doing.
So as long as you're not giving it a direct order, then it doesn't count. But if it's just like one after the other without you having to do that, then it's considered serial.
Right. So until you go and organize it, until you go and rearrange it, then it's going to be ordered. But technically, serial is on order because as you accept it, you put it in. But technically, this is just a technicality. It's actually going in an order, a time-based order. But based on something you just said, I actually realized that serial might not be it. Because notice, see if you can read back the first one and see if you can figure it out. Meter reading records submitted by customers monthly. Meter reading records submitted by customers monthly. Do we stick with serial? By customers monthly. Yeah, I think serial is gonna work. Meter reading records submitted by customers. I was thinking that maybe they wanted us to sort it by customers, but not necessarily that. Yeah, we can stick with serial. B, personal data of customers in a master file.
Could that be sequential or direct?
Sequential or direct? It's gonna need
I'm thinking partially in the
something along that line. It's basically going to need an index, some form of ID. It's gonna need. Once you see that word master file, think of we're talking about database here. All of these file methods, we're actually talking about database.
So the master file would have like smaller files inside that you would like just explaining with the cassette thingy, like chapters. So if you want to skip through it, you can put it as an index so you can actually get it.
No, look at diagram here of a master file. So this is the, think of the master file as the database. Think of it that way. I didn't even spell database correct. Yeah, think of the master file as the database that has all the data inside of it. Now, this is how a database, a high-end database works. You have what is called a transaction file. The transaction file has the changes inside of it. So this is, the transaction file has changes inside of it. And this changes now is going to be updated to the, is going to be updated. So now you're going to get an old master file and you're going to get a new master file. So basically an old master file without the changes and a new master file with the changes. So if we look at the diagram, let me erase all of these things here. So if you notice, you take the old master file or the current master file, let's use that word, current master file, and you combine it with the transaction file, the changes, you're going to get a new master file. And then technically now, the current is going to become the old. So the master file is basically the total data, all of the data basically. So now we just got to figure out what is the file organization of this here. All right, so I didn't see anything mentioned. let's go back to the question. Personal data of customers in a master file. What file organization method would be used for storing data in a master file?
Sir, for the question, right? It said that personal data of customers, right? Like plural, wouldn't it be sorted in a way?
Yes.
So doesn't it count as sequential?
But you're gonna need an index. But that's what we're trying to find out, which kind of index. But I would assume a fully indexed file. So if you read the description, it's going to be sequential, and look at fully indexed. It's a sequential access, so it gets the characteristics of sequential, but you're going to get direct access because each person now is going to get an ID for you to go directly to that person. Yeah, I think that would be the answer. We'll go with that one. Any objections? Or you still want to go with sequential?
No, it makes sense for it to be fully indexed.
No objection.
To store each customer in an organized manner with an ID. That's basically what the fully index is going to do. Store them in an organized manner, give each person an ID. Now, customers' username and password.
Sir, would it be a direct access file?
And why?
Because from the description it says it provides the location followed by the direct access to the record. So if you're typing something like the username, it gives you direct access to your account or something in that.
Because it doesn't necessarily have to be in order. Anybody else? And the internet is not telling me anything. Let me see if I get this thing to do it. Login. with Google. Anything from Tamika? File organization method for
I'm the last one.
huh? Okay, so I think you got the answer here. So it says when it comes to storing customer usernames and passwords, it's generally best to store random values rather than sequential. Using sequential values such as incrementing integers can make it easy for someone to guess another user's login credentials simply by guessing the next value in the sequence. So on the other hand, using random values for username and password makes it much more difficult for someone to guess another user's login credential. Yes, so we're going to go with direct access file. So randomly store the username and password. Good. Any questions? So that's the last.
No, sir.
That's the last part.
Sir, for a partially indexed file, what would be an example for that?
So it's not technically I can't think of an example, but it's basically how it works. So it's sequential, that's the first aspect, followed by direct access to the first record in the group, then sequential access to find the desired record. So based on that description, I would assume that it has like groups of data like this here, and each might have an index 1, index 2, index 3, index 4, and it might jump to index 2 and then go through sequentially. Whereas fully indexed now is going to be one large index data, and each of them is going to get their own individual index number. Hence the name partially indexed and fully indexed.
So for the partially indexed, you can skip to a whole part, but then you have to go through sequentially.
Right.
But with the fully indexed, you have to skip through all of them and then get to the specific one and then go through that.
No. Fully indexed, you can jump to the index number.
So you can skip to any.
Right.
But then with the partially, you have to
find a block.
go in the.
So think about the fully indexed first. This rectangle that I have here, that's all of the data. And each piece is going to get an ID index number. So now you can jump to each index number. So it's fully indexed. Each piece of data has an identifier. So you can jump to any one identifier. But the partial index, it basically takes a lot of work to index each piece of data. Think about a supermarket. It would take a lot of work to identify each individual item with a unique number. So you can think about it that way. Like just like how you see in the supermarket right now, it would take a very long time and a lot of work to give each one of these products a number. And that's what fully indexed does. So it takes a lot of processing power. Now, to minimize that now, they can take a group and give it an index number 1. Take another group, give it index number 2, like how you see in the aisle number. And then you run through it sequentially.
I think I understand it better.
Mm-hmm. Direct is always random, so you can just jump anywhere. Direct is kind of like fully indexed, but with direct, there isn't a necessity that, or it isn't necessarily indexed. It could not be. Any other questions?
No, sir.
That was actually the first time. I don't know. I don't think that was the first time. I think he had another paper, but it didn't went so in depth into that question that I had to go through the chapter like how I went through the chapter there. Yeah. Any questions before we close? Because we're gonna wrap up here. All right, no questions. So we can stop here for tonight. Enjoy the rest of your night.
That's it.
Bye, sir.